Welcome back to All This Math. This is Professor Parker. Make sure you're subscribed to the channel if you're not already. Please hit the like button, like this video, share this video with somebody else, and also drop a comment down below if you have a question about something that I attempt to explain, or if you have a comment about something that I attempt to explain. Please, drop a comment down below. I want to run the comments up. All right, so what are we doing today? Today, we are responding to a parent that reached out to me, was like, this is the work that my son is doing in his class. He doesn't really understand it, So I said, all right, I'll make some video content about it, right? I'll try to give him an explanation that maybe his teacher is not able to provide, all right? So we're dealing with complex numbers. Now, what makes a number complex? A number is complex when it includes what we call an imaginary number. An imaginary number. So yeah, imaginary, like fake, like delusional, right? These are all words we should be familiar with, fake people, delusional people, whatever, right? But before I even get into the mechanics and like how to actually do the problem, I think it's very important that we understand what an imaginary number is. Because if we read the instructions, it says to express in simplest a plus bi. A plus bi is the format, right? That's how we're going to write it. That's the formula, right? A plus bi form, all right? Now, the variable a represents a real number. Then you got your plus sign, and then b represents a real number. But notice that b is really a coefficient of I. I represents an imaginary number. I, the first letter in the word imaginary is I. So whenever you see an I, that's an imaginary number. Now you might be thinking like, what's an imaginary number? All right, it's kind of like this. Like earlier, right? And when I first started talking, I threw some words out like fake, delusional, right? Think about people. There are real people in the world, people that stand on business, people that are serious, people that are honest, people that are trustworthy. And there's some people that are fake, very opportunistic, do anything to get by, don't have no morals, no principles, no integrity, right? We probably try to stay away from those people, but they still exist, right? They're in our communities, they're in our spaces, they're in our schools, right? We got to learn how to coexist with them, just like with numbers. With numbers, we may encounter a situation where we find a number that's imaginary, that does not act according to accepted rules of behavior, right? It's like if somebody's real, that means you stand for principles, you stand for something, right? People that are fake don't stand for nothing, right? They're just trying to get over, trying to get by in any situation. So what is an imaginary number though? An imaginary number is the square root of a negative number. I'm going to say it again. An imaginary number is the square root of a negative number. Now, when you hear somebody say that, that should sound crazy, because how are you going to take the square root of a negative number? Think about what a square root is, right? For example, what's the square root of 100? The square root of 100 is 10, because, well, we call that the principal square root. It's also negative 10. I'm going to tell you why in a minute. The square root of 100, the principal square root is 10 because 10 times 10 equals 100. Negative 10 is also the square root. It's an alternative square root because negative 10 times negative 10 also equals 100. So a square root is a number that can be multiplied by itself and equal a certain product. Maybe not larger, I shouldn't say larger, but equal a certain product. So ask yourself this question. How can you ever multiply a number by itself and end up with a negative number? I'll wait. I want you to think about that. How is that possible if you know the rules for multiplication? The rules for multiplication say when you multiply two negatives, your product is a positive. When you multiply two positives, your product is a positive. So if you're multiplying a number times itself, you're always going to end up with a positive. That's the rule in the real number system, right? But when you take the square root of a negative, because sometimes you might encounter that, like we're gonna see in this problem. You might deal with a situation where you end up with the square root of a negative number, right? That's imaginary. That's not real. So we got a word for that. We call it imaginary, and we represent it with a lowercase I. So that's just a little background on like what this really is and like when you're going to see it. Now, if we want to express this in simplest form, we look at the problem. It says the quantity. We don't say parentheses. We say the quantity of 6 plus 5xi times the quantity of 4 minus 5i plus the quantity of 6 minus 5xi times the quantity of 4 minus 5i, right? This is called a binomial. Why is it a binomial? Because the prefix bi means two. Just like a bicycle got two wheels, This got two terms. 6 is one term, 5xi is another term. These three parts together make one term. The 5, the x, and the I together make one term. So that's a binomial and that's a binomial. Now there's a method that I like. Some teachers don't like it. It's called the foil method, like aluminum foil, like after the cookout, wrap up a plate, put some aluminum foil around it. It's called the foil method, right? That you can use to multiply two binomials. Now you can't use it with two trinomials when you got three terms and three terms. You can't use it when you got a binomial and a trinomial, when you got two terms and then three terms. That's why some teachers don't like it, because you can't use the foil method all the time. But my thing is, I believe in teaching students the ability to be discerning and know when they can use something and when they can't use something. I'm all about that. But if you don't like the FOIL method, what you end up doing is saying, okay, take this first term here, the 6, you multiply it by both of these terms, one at a time. And then you take this 5xi, multiply by both of these terms, one at a time. Now, that's something that you do regardless of whether you got a binomial, a trinomial, whether you got 4 terms, 5 terms, whatever, right? But it's just that the FOIL method is a way to remember what you got to do. The F in FOIL stands for first, meaning the first terms, the 6 and the 4, right? The O in FOIL stands for the word outer, meaning the outer terms in terms of position. The I in FOIL stands for inner, the inner terms in terms of position. The L in FOIL stands for last, meaning the last term in this parentheses or this binomial and the last term in this binomial. It's basically telling you what needs to get multiplied by each other. So therefore, you make sure and multiply everything together that needs to be multiplied, right? So, all right, so let's go ahead and do it. Let's get to it. So first, I'm going to do 6 times 4. Now, you got to know your multiplication facts. You should not be taking out a calculator to do 6 times 4, right? If you're in that situation right now, you got to catch up, man. You got to like learn your multiplication facts, right? You need to know that off the top of the dome. So 6 times 4 is 24, right? Then we're going to do 6 times negative 5i. So 6 times negative 5, again, you need to know what 6 times 5 is. And then 6 times negative 5 is negative 30. But the I is there too. So that's minus 30i. Then we go to the 5xi. 5xi times 4, right? Now, also, I got videos on this channel in a different playlist about multiplying binomials and using the FOIL method if you need to brush up on that. So you can like go holler at those videos too. So 5xi times 4 is plus 20xi. And then 5xi times negative 5i is going to be negative 25. Where did 25 come from? Because 5 times 5 is 25. That's why. And then we got x. There's no other x term, so that's going to be part of the product. Then we got I times I, which is I squared. Now, something else you should know about imaginary numbers. So I, like I said, is equal to the square root of negative 1. Actually, I didn't say that, but I kind of gave you that general idea. I squared is equal to negative 1. Because what happens when you square the square root of negative 1? The exponent 2 and the radical sign cancel each other out, leaving you with just that radicand. We call that a radicand when it's inside the radical sign, negative 1. Now, I know I'm saying a whole lot, I'm throwing a lot of terminology at you, vocabulary. The beauty of this, it's a video. You can run it back, just like you run back any video on YouTube, right? You can pause it, run it back if you don't understand something. All right, so look, I multiplied these two binomials out. I got these 4 terms. Now I'm going to do the same thing over here because it's plus the product of these two. So I'm going to do 6 times 4. That's 24. Then I'm going to do 6 times negative 5i. That's negative 30i. Then I'm going to do negative 5xi. Hope I don't run out of space. Negative 5xi times 4. That's going to be negative 20xi. And then I'm going to do negative 5xi times negative 5i. That's going to be plus. Because what happens when you multiply negative by negative? Your product is positive. When you multiply negative by negative, your product is positive. All right, so it's going to be plus 25. And then we got the x. And then we got the I times I. I times I, that's I squared. All right, so now we got 1, 2, 3, 4, 5, 6, 7, 8 terms. Now what we got to do is something called combining like terms. So in order to do this problem successfully, you need to know how to multiply binomials. Like I told you, I got a whole playlist on videos like that. You also need to know how to combine like terms, or some books call it collect like terms, meaning you put the like terms together. You can only add and subtract what we call like terms. A like term is, well, all constants are like terms. So numbers, positive, negative, big, small, decimal fractions, they're all like terms. If there are variables involved, They're only like terms if they got the same exact variable with the same exact exponent. So x and x squared are not like terms because x has an exponent of 1, x squared got an exponent of 2. They ain't like terms. You can only add or subtract like terms. You can only add or subtract like terms. You can multiply or divide them if they unalike, but in order to add or subtract them, they got to be alike. So let's look for like terms. So I see a 24 and I see a 24. Those are constants. I'm going to add them together. And then I see a negative 30i and a negative 30i. I'm going to put them together. And then I see a positive 20xi and a negative 20xi. Oh, these are like terms, but these are exact opposites. So what's going to happen? They're going to cancel out. Because what's positive 20 plus negative 20? Positive 20 is like you got $20 in your pocket. Negative 20 means you went and spent $20. Now how much you got in your pocket? Zero, donut, nothing. All right? Positive 20 minus 20. Then I got negative 25xi squared plus 25xi squared. Oh, these about to cancel out too. So they cancel out too. So they going, because I had like negative 25 means you owe somebody $25. Plus 25 means you get $25 from somewhere. And then what do? You do the right thing because you're honorable. You pay the person back that you owe. You pay back your debts. You pay what you owe. Now you break even. So you don't have no money, but you don't owe no money. So you're at zero with that person. Negative 25 plus 25 is zero. See, math also teaches character. All right. Some people ain't catch these lessons. That's why they be not paying back their debts. It's crazy out here. So anyway, now we combine like terms. You got a 24 and a 24. What's 24 plus 24? Again, you should not need a calculator for this. You need to know how to add numbers, subtract numbers, multiply numbers, divide numbers in your head. In your head. You should not need a calculator. You should not need Chat GPT. You should not need none of that. You got to practice and get to the point where, and I know your calculator can do it, but so what? You need to know how to do it. All right? So 24 plus 24 is 48. And then, how do I know those are like terms? I underline this one, I underline that one. That's a way that you can, on your paper, right? You can remind yourself of what the like terms are, what goes together, what goes with what. All right? Just like, after you do your laundry, take your clothes out the dryer, match up your socks, right? That's all we're doing. It's the same exact concept. So then we got negative 30i and negative 30i. Negative 30 plus negative 30 is negative 60. Negative 60i. So 48 minus 60i. This is our final answer. It's in the a plus bi form. A is the first term is a real number by itself. And then we got plus. You might be wondering, well, that says plus though. Yeah. Subtracting something is the same thing as adding a negative. So this minus sign is cool. This minus sign is cool. But if you had that question, that would be a valid question. That's a good question because this is a plus sign. This is a minus sign. But just know, subtracting something is the same thing as representing adding a negative. So I could rewrite this as 48 plus negative 60i. These two expressions represent the same value. Adding a negative is the same thing as regular subtraction, right? Now, the b is another real number. That's negative 60, right? And then you got your I right there. So this is how you express an expression in simplest a plus bi form. So all you had to know how to do was multiply binomials, because this is a binomial, that's a binomial. This is a binomial, that's a binomial. You got to know how to multiply binomials, right? I got videos on the channel that show how to do that. Tap in, all right? And then you got to know how to combine like terms. You got to know how to combine like terms, right? Now, if we had not canceled out, let me talk about this real quick. If we had not canceled out this negative 25xi squared and this positive 25xi squared, we would have had to convert this I squared to a negative 1, and then that would have made this into, something different, right? Sometimes you have to convert the I squared. So whenever you see I squared, just get into the habit of just converting it to negative 1 and then multiplying it by the rest of the parts of that term. All right? So that's how you do this. And also, since I got it on my t-shirt, I want to give a shout out to Harriet Tubman. Make sure you do your research on Harriet Tubman. I know we hear about Harriet Tubman all the time. Every Black History Month, we hear about Harriet Tubman. But ask yourself this question. Do you really know about Harriet Tubman? Have you read any books about Harriet Tubman? And I'm not talking about them elementary school picture books. I ain't talking about that. I'm talking about some real biographical information, right? I mean, and nowadays, 2025, it's even more important than ever to really read about Harriet Tubman, because you got people walking around talking about she ain't exist. Like, really? Like, all right, yeah, people really need to read. I highly recommend read some books about Harriet Tubman. All right, so go practice these types of problems dealing with complex numbers, a+bi form, you know, multiplying binomials together and combining like terms, and go study Harriet Tubman. I see you on the next video. Peace.